that is, I think, the world that we are entering, which is, we don't need to train these models to know everything. We don't need to train these models to be ultra capable. We need them to be good enough, teach them the ability to think.
In this episode of Embedded Insiders, Rich and I sit down with Sid Sheth, CEO and co-founder of D-Matrix, to explore the ongoing generative AI boom, why it's becoming increasingly unsustainable, and how D-Matrix is addressing the challenge with a chiplet-based compute architecture built specifically for AI inference. Next, Ken brings us up to speed on some of the week's top embedded industry headlines, with updates from Asus IoT, LG, and Microelectronics UK. But first, Rich, Ken, and I share our thoughts on the state of generative AI and AI inference.
Hello, engineers, developers, and friends. Welcome to another episode of Embedded Insiders Podcast. I'm Ken Briota, Editor-in-Chief of Embedded Computing Design, and I am here as often as possible with Tiara Oliver and Rich Nass. Hello, guys.
Hello, Ken.
Today is not at all my discussion, so the floor is yours, Tiara. Tell us a little bit about what we're going to palaver on.
Yeah,
Palaver? Well,
So
hold on.
next-
I got to look up that word, palaver. All right. Sorry, Tiara.
so in the next segment is an interview Rich and I actually did a few weeks ago with Sid Sheth. He's the CEO and co-founder of D-Matrix. And we talked to him about AI inferencing, generative AI, and a little bit about sustainability. And the general conversation was training giant generative AI models is expensive, and it takes massive GPU clusters, a lot of power, and most companies can't even afford to do it, which makes AI hard to scale and accessible for everyone, and it's not sustainable. So their solution or idea was smaller but still smart models. So instead of relying on huge models, distill them down, shrink them without losing much of the performance. So D-Matrix isn't just building AI chips. They have accelerator cards, software, hardware stack that's optimized to run generative AI faster, cheaper, and with less energy. Those are his words. So the solution is built to run any AI model with those three factors in mind: time, money, and energy, which is supposed to be this key to making AI more accessible and sustainable. What do you guys think?
I find the whole phenomenon so interesting. We're so at square zero of the whole AI phenomenon. And I think we're going to look back in a few years and we're going to laugh at how primitive some of these solutions are. But you have to, what is it? You have to crawl before you walk. You have to walk before you run. And I think that's where we are. But it's pretty cool. But one of the things you brought up that is a potential roadblock is the power that's required to drive these things. And what you just described is actually one really good way, I won't say to avoid it, but to help and facilitate the massive power that's needed. But why this is interesting to me right here and now, I just recorded a podcast that'll be released in the next couple of days. We talked about the interconnects around the power delivery within the AI data center. We spent a whole lot of time talking about the power devices themselves, all the silicon carbide and the GaN and all the other stuff that's needed to drive these things. But we don't talk about the interconnects. And when you're pushing so much power around on a 24/7, 365, you just need better hardware. And in this podcast that I did with Point Two, we'll learn about one of those potential techniques.
Yeah, I think the AI situation and the power is all really interesting, especially in the efficiency and green discussion, which Tiara, did you guys get into that at all on the energy efficiency side?
We didn't talk as much about it as I would have liked to, but I think the whole at least what I find interesting about this, even what Rich is saying about the interconnects, is when we talk about AI, I feel like you never think about the hardware and the hardware's role in just bringing it to life and how it can possibly help make it more sustainable. I don't know.
Well, folks, it looks like you're just going to have to continue on and listen to the interview to find out more. And I hope you do. Meanwhile, if you've been sent this by an extremely caring and trustworthy friend, make sure that you subscribe right away so that you don't miss any future episodes of Embedded Insiders or any of our other podcasts. And we hope we'll see you again next time.
Now, here's Sid Sheth, CEO and co-founder of D-Matrix.
D-Matrix is an inference compute company that we started in 2019 with the focus around making generative AI accessible and affordable to everyone, and making it commercially viable. So that's what we are working on, building computing solutions that will be focused on accelerating generative AI with an emphasis on commercial viability.
Was there even a need for this in 2019?
Yeah, that's a great question. No, I don't think so. I mean, I can tell you, when we started the company in 2019, all the conversations we had were, people didn't think this would happen anytime soon, right? I think we got CPUs, we've got GPUs coming next. Do we really need dedicated inferencing accelerators? Training is really where all the narrative was at the time. So no, nobody. I think it was very, very hard for us to be out raising money with that vision, right? Because we were pretty clear that we wanted to focus on the data center market, and it was not very clear that inference would become big in the data center. A lot of people said inference in the edge, and that was the hot topic then, but that really didn't take off the way most people thought. But inference in the data center is now the biggest workload. So yeah.
Yeah, that's a pretty good feather in your cap there.
Yeah, no,
Okay.
I think I like to say it's 50% luck, 50% insight, right? We certainly
Or
did
is
our
it
part,
80% luck?
and maybe 90% exactly. I think what we did was there was times along the way where we were challenged, right? I think we were asked the question whether this is really the right path, and is this really going to be a big opportunity? And I think the credit goes to the team here. They stayed the course and they didn't give up, and here we are, right? I think we're being rewarded for staying the course.
So, Sid, some would describe generative AI or the generative AI revolution as unsustainable. What are the primary factors driving this concern in your opinion? And maybe how do you see the industry adapting to these challenges?
Yeah, so I think we should take a step back and you kind of break down. If you go down to the computing layer or the infrastructure layer, really there is three primary different types of computing workloads when it comes to AI, right? There is what they call pre-training, there is post-training, and inference. And the last 10 years, really AI, AI specific computing has really just taken off in the last, call it 10 years, right? The thing was, most of the emphasis was around training, as I just mentioned earlier. The pre-training part, that is the first aspect of just training AI models, and there was really no, really the focus was on training the biggest models available, right? So I think the trajectory for AI was, can we train bigger models? Because the natural belief was, and it was true, that the bigger the models became, the smarter they became and more capable they became. So bigger is better, and keep training bigger and bigger models. And for the last 10 years, at least, the trajectory has been around spending a lot of CapEx dollars with a little emphasis on return on investment, with a little emphasis on user experience. Okay, once we train these bigger models, how does this really impact users? And again, a lot of emphasis has been on a single modality, which is text. So most of the interaction you have with AI today is in textual form. So really, this has been the narrative of the last 10 years, and that's where the world has been. And I think we are entering a new world where people care a lot about ROI, they care a lot about user experience, different types of modality, like video, speech, images, etc., are kind of coming into use. And when you talk about that first phase, pre-training and training bigger and bigger models, it's a capex problem. You're just throwing a lot of GPUs at the problem to train bigger models, and that slowly became the domain of a very few companies on the planet, right? I mean, there's really only 4 or 5 companies that can even afford now to train the next biggest frontier model by building massive GPU clusters that cost tens of billions of dollars, right? It is really not something that most companies on the planet can afford, um, and um, and that is where AI becomes unsustainable. Is how do you take stuff that only 5 companies can produce and make it generally available to pretty much everyone, so that everyone can partake in the benefits that AI has to offer, right? And I think that is where inference comes in, specifically. So once you have trained models, you don't need to really train models beyond a certain point. Models are already very capable. So I think there is this new trend around taking bigger models and distilling them down to smaller models and then running inference in a very efficient manner. And that's where D-Matrix comes in. We build solutions that help run inference in a very, very efficient manner. And that is something that is more viable and affordable to many, many folks on the planet, many enterprises on the planet. And you really need that to happen for AI to truly proliferate and become accessible to everyone. And that is what takes out that unsustainability piece, which is, it's affordable only to 5 companies versus it proliferates and is affordable to pretty much every enterprise, every company on the planet. And they find a way to use it and generate an ROI with that, right? And that is what D-Matrix is focused on, the second part.
Does that make you very beholden to the hardware guys? I mean, there aren't that many people who do what NVIDIA is doing, for example.
So we are obviously building our own computing solution. We are building the silicon. We build the accelerator cards, right? We are building a whole stack, the software and the hardware, to service the inference computing opportunity. And we have essentially built the solution from the grounds up, targeted for generative AI inference, with efficiency in mind. And when we talk about efficiency, it's about doing more with less. So it's about doing more compute with less dollars. It's about doing more compute with less energy. It's about doing more compute in less time. Really, time, dollars, and energy are the 3 key resources that everyone is optimizing around, right? So you want to essentially build something that generates an ROI on those 3 key resources: time, dollars, and energy. So we have built the solution to do more with less with those 3 key things. And our solution has been built to essentially run any AI model, right? You can train an AI model on any GPU. It could be an NVIDIA GPU, could be any other GPU. And then we can ingest that trained model onto our solution and pretty seamlessly run that on our hardware, but it's just going to be a lot more efficient.
Going back to that same point, you've talked about how these models need to think more. And I know it's a podcast, but if you could see me, I'm doing air quotes around think more. What do you mean by that?
Yeah. So, going back to that original point I was making, we are kind of entering a new world, right? The last 10 years was all about training bigger models and using a lot of capex to buy a lot of GPUs, and there was little emphasis on user experience, and most of the modality was text. We are entering a new world where now ROI matters, return on investment matters. People care about what they do with all those capex dollars. They care a lot about user experience. How do we make AI really accessible to a lot of people, which means user experience matters. And users don't only want to interact with AI through text, they want to interact in other forms of modality. So I think all of this is changing. And the other thing that is also happening is a new class of models called reasoning models are entering the fray. So you have DeepSeek recently was the first company to open source a reasoning model. Now there is a multitude of reasoning models that have been open sourced and readily available. And that is where, my comment about think more versus train more, comes in, which is, as opposed to training models to do more and more, can't we get a model to think more and kind of work for us as opposed to we having to work for them? And good analogy here would be, it's like sending somebody to school and college, and you can get your first PhD degree and your second and your third, and you can get 5 PhDs. After a while, the fifth PhD or the fourth PhD doesn't make you any smarter, right? You're only collecting a lot of knowledge. But really, the smart folks are the ones who know how to apply that knowledge, and they don't necessarily need to learn everything, right? You can have a person who went to high school and is just very good at applying the knowledge that they can get access to around them and monetizing it. And I think that is, the world that we are entering, which is, we don't need to train these models to know everything. We don't need to train these models to be ultra capable. We need them to be good enough, and you teach them the ability to think, and they will be able to then tap into a repository of information. There is, something called RAG, right? Where you can essentially have a database of information sitting behind the model. So the model doesn't have to be trained on all that information. It has been trained to think. And every time it needs access to information, it can go access that database, right? And always find an answer to the question you're looking for, or assimilate that, all that information into an answer that it can put together for you after a lot of thinking. So I think we truly believe that as we enter the world of reasoning and agents, where agents will be taught how to think, the think more versus train more paradigm will be the most popular one, and obviously will truly allow AI to proliferate to everyone.
I'm good with that, but I think the person with the 5 PhDs might take some issue with your comments, but I'll leave it at that. Just be clear, you said that, not me.
Yeah.
So Sid, you mentioned GPUs. Can you explain how AI inference and low latency and batch throughput can enhance existing infrastructure to accomplish what GPUs can't?
Yeah. So I think, again, the world that we're entering is a world where no one computing solution will win it all, right? Yes, there will be a dominant computing solution, like you might have GPUs having bulk of the market in the near term. But when you enter the world of inference, which is where we are entering the age of inference. We talked about reasoning models. Reasoning is all about inference, or they call it test time compute or inference time compute, where the models are thinking in real time, and then they kind of present an answer to the user. As we enter that age of inference, this is going to be a world where there is different forms of compute that are needed. So we're entering a world of GPU and other forms of compute. So it's a heterogeneous world, and GPUs are not going to be good at everything, right? There'll be other solutions that are good at cost optimizing, latency optimizing, throughput optimizing, right? And the D-matrix solution specifically is focused on what we call low latency batched inference. And what we are finding out, based on our conversations with customers, that a lot of enterprise applications really don't need a lot of batching, right? They don't need thousands of users using the application at the same exact time, right? And you have consumer applications. For example, ChatGPT is a good example of that. It's a consumer application where you might have hundreds of thousands of users all using the application simultaneously at the same point in time. But when it comes to enterprise class applications, you typically don't have that, right? So there is a need for a solution, a computing solution that can be fully optimized to service that type of need, which is you don't really want to be servicing more than a certain number of users at any given time, but you want to offer each user a highly interactive experience, right? So you want the user experience per user to be not compromised, while at the same time, you want the computing solution or the hardware to be fully utilized with that smaller number of users, right? And that is what we have built. And I think there is going to be a place for that type of solution, because not all applications can run on very expensive, highly compute intensive GPU hardware, right? Because it's very difficult to keep all of that hardware fully utilized. It costs millions of dollars. And to keep it fully utilized would require extremely large workloads, lots of users simultaneously using that workload, which is not what everybody needs. And that is where the low latency batched throughput, use case is very well suited for a broad class of enterprise applications.
Okay, so you're pretty good at seeing into the future. Let's pull out the crystal ball. Where are we going to be, say, 3 years from now?
I wouldn't say I'm great at looking into the future. I think I think we just make some bets and
I said pretty good. Okay, let's just be clear.
Yeah, we hope that we get lucky. But yes, I think if I were to look at a world that is 3 years out, I think it's a world where you are going to have these reasons. As I said, we are entering the age of inference. We are entering the age of inference time compute or reasoning, and that is going to lead to a world of agents. So we are entering a world where enterprises are fundamentally going to look very different in the way they go about getting their work done, right? You're going to have thinking AI or thinking agents that are fully infused and embedded into enterprise workflows that can understand very simple instructions in English at a very high level, can comprehend those instructions, break them down, can then collaboratively work with other agents in other verticals of the enterprise, and really work as a team to get pretty complex tasks done, right? And so you're going to see a huge amount of productivity gains coming into the enterprises, right? And that is going to be heavily driven by these agentic workflows helping break down pretty complex tasks and being able to comprehend pretty simple instructions to execute on those tasks.
Now, here's Ken Briota's In Case You Missed It Embedded Insights news show.
Hello, embedded engineers and developers. Welcome to In Case You Missed It Embedded Insights, the weekly news show all about embedded technologies and solutions from embedded computing design. I'm Ken Briota, editor-in-chief of Embedded Computing Design and your host, and these are our top stories this week. First up, very excited to tell you that Land Rover, Jaguar Land Rover, Rolls-Royce, and ESA have all joined tech industry event Microelectronics UK, which is a big event in the UK in a drive to promote embedded industry growth in the United Kingdom. At that show, Lord Patrick Vallance, who is the UK Minister of State for Science, Research and Innovation, and is also a former government chief scientific advisor, will be making the keynote address. So check that event out at the story down in the description. Our next story comes from Asus IoT, which has written a great blog for us on edge-based AI in healthcare specifically. Smart healthcare is rapidly, as everyone knows, becoming a key technology for improving the quality and efficiency of patient care, while also enhancing the safety features of medical facilities. And in some cases, these edge AI systems are even saving lives. So make sure you check out that column from Asus IoT. Finally, we're featuring a behind-the-scenes look into smart manufacturing. Our own production editor, Chad Cox, was invited to tour LG's Lighthouse factory recently, and he's written a deeply insightful column full of deep insights into the AI, automation, and manufacturing technology of LG's most advanced factory. You really want to take a look at this. The factory's in Tennessee, and they're doing some really, really exciting stuff. But while you're at it, make sure you look for the In Case You Missed It LinkedIn newsletter for even more stories that you don't want to miss all over our site. That comes out every Monday. You can subscribe on LinkedIn. Of course, make sure you subscribe here on YouTube so that you never miss any episodes of In Case You Missed It or any of our other shows, including Dev Kit Weekly. Our LinkedIn newsletter comes out every Monday, and of course, this show comes out every Friday. Visit embeddedcomputing.com for all the news in the embedded computing space, and follow us on LinkedIn and all across the web. Please reach out if you'd like to become an advertiser for any of our shows. Make sure that you let us know if you have a story idea that we've missed. That's our show, and I will see you next week. Thanks, everybody, and have a great weekend.
Thanks for listening to this edition of Embedded Insiders. For more daily news, videos, and podcasts, visit our website at embeddedcomputing.com.